This is our chapter on rational expressions and equations. The things that we are going to be covering in this chapter include simplifying rational expressions, multiplying and dividing rational expressions, reviewing the LCM, adding and subtracting irrational expressions, solving rational equations, and of course we're going to apply that using something called the work principle. To simplify a rational expression, and a rational expression simply means that you have your variable in the numerator and in the denominator. So since we have the variable in the denominator, this is a rational expression. In order to simplify it, we need to remember that we cannot cancel terms, that we can only cancel factors. Terms are the stuff that's being added or subtracted, and factors are the stuff being multiplied. We do not have factors yet in this expression, as the top is a trinomial and the bottom is a trinomial, or three terms. So no matter how badly the x squared on top and the x squared on the bottom look great to cancel, it's illegal in math land to do that. So instead we factor. We take the top and the bottom separately. So on the top, since this is one of my easy kind of trinomials, I break it into two parentheses and say what times what is x squared. I get x and x. Now I need two numbers that multiply to a negative 8 and add to a negative 2. Well, since my last number is negative, I know my signs are going to be one of each, because that's how we multiply to get a negative. It's a mismatch. So I need two numbers that'll multiply to 8 and add to that negative 2. Well, since it's adding to a negative, my bigger number is going to have to be negative, so I'm going to put the 4 over here and a 2 on this side. We're going to go through the same type of procedure on the bottom, the x squared minus x minus 6. I don't have a greatest common factor, so I go straight into my two sets of parentheses. It's only an x squared, so I know that the only way to do that is an x and an x. Now I need two numbers that multiply to a negative 6 and add to a negative 1. Remember, if there's no number in front of the x, that means that there's a 1 there, because 1 times anything is anything. Once again, because it has to multiply to a negative, I know I need one of each sign, so I may as well put those in right away too. Now the two numbers that multiply to 6 and add to a negative 1 is 3 and 2. Once again, it has to add to a negative, so my bigger number has to be negative, and my smaller number is going to be by the positive. Now that it is in factored form, I am allowed to cancel factors. Factors are the stuff that's being multiplied. So anything that's in parentheses is being multiplied by something else in parentheses, and that allows us to cancel it. So in this case, we have x plus 2 on top and the x plus 2 on the bottom. You cancel the entire quantity or none of it. Anything over itself is 1. Anything times 1 is my anything. So my final answer will be the x minus 4 over x minus 3. Now those factors were in parentheses up here, but they're not down here, mainly because I'm not needing the parentheses to indicate that I'm multiplying those by anything. But if you want to keep the parentheses in there, that's okay to do. Remember, you cannot cancel those x's because those are terms. Now let's try multiplying. The only difference in multiplying rational expressions from our simplifying is that there's more things out there to factor. But it's going to be the same procedure. Factor all of your numerators, factor all of your denominators, cancel common factors that are shared on top and bottom, and then simplify. So we go through every numerator. X plus 4. First thing we always look for in factoring is a greatest common factor. There isn't one between an x and a 4 besides 1, and that doesn't do a whole lot for us. We look then to see, can I break that down further? Well, because my x is just an x and not an x squared, I can't break x down to anything smaller. So I know that the x plus 4 is as far down as I can make it. Now that means that that's whole quantity though, x plus 4 is a factor. So I'm going to write it in parentheses to remind myself that yes, I looked at it, and also that that entire quantity is a factor. So I would cancel all of that or none of it. The x on the bottom, there's nothing I can do with x, so it just comes along for the ride. I'm still multiplying. Now my other top, once again, the first thing we always look for is a greatest common factor. I notice that in these two terms that each of them have an x. So I'm going to pull out that x. Here I had two x's, essentially, that's what x squared means, x times x. I had pulled one of them out, so I'm left with one left. Here I pulled out the x, so I'm left with the minus 3. The binomial I can't break down any further because once again it's x to the first power. Now I do the same idea with the bottom. It's a trinomial. I do not have a greatest common factor in all three terms, so that means I make my two sets of parentheses to unfoil it, essentially. Once again, it's the easy kind of trinomial as there's only a 1 in front of your x squared, so that means I'm going to start off with x and x. I need two numbers that multiply to a negative 12, so once again I'm going to need a positive and a negative. And it's going to add to a positive 1. Well, that's going to be a positive 4 and a negative 3, as 4 minus 3 is 1. Now that I have all of my parts factored, I get to have the fun part and cancel. Anything on top that matches anything on the bottom cancels out. Now I have an x minus 3 on top here and an x minus 3 on the bottom, so I'm going to cancel those out. I have an x plus 4 on the top and an x plus 4 on the bottom. Those cancel out. Oh look, I have an x on top and an x on the bottom. So what am I left with? Whoa, slow yourself down. Canceling it out doesn't mean that you get 0. We started with something here. Remember, with multiplication, the only way that we get 0 is if one of our numbers was 0. We don't have anything. What do we have left when we cancel stuff out? Anything divided by itself is 1 is the loneliest number that I've ever known, number 1. So the final answer to this problem is 1. When everything cancels, you're still left with 1. Dividing rational expressions is just like dividing any other fraction. You have to remember the rhyme. Dividing fractions is as easy as pie. Flip the second and multiply. Okay? We multiply by the reciprocal is the high-tech words to it all, if you prefer. And that simply means that we have to leave the first fraction as it is. So I have 4y minus 8 over y plus 2. I change my division into multiplication, and then I flip the second fraction, which means the bottom becomes the top and the top becomes the bottom. Now it's a multiplication problem just like the previous one. We factor each of the numerators and each of the denominators and see if we have factors that cancel, and then we simplify. So in my 4y minus 8, I notice that there's a greatest common factor. 4 goes into both of those terms. So I'm going to pull out the 4, which would leave me with a y minus 2. Make sure you divide and not subtract. Remember, you can always check by distributing back in. 4 times y is 4y. 4 times 2 is your 8. On the bottom, I have y plus 2. There's no greatest common factor there, and y is to the first power. When there's no power up there, remember that's God on your shoulder. He, she, it is always with us. The God of Mathland is a 1. Since it's y to the first, I cannot break that down any further. Like I did on the earlier problem, though, I want to put the y plus 2 in parentheses to remind myself that it's that entire quantity. You need to think of it that you pulled out a 1 out of there, and it's out in front, so you have 1 times that quantity. You can think of it that way as well. Then we continue on. Y squared minus 4. No greatest common factor there. And we have two terms. When we have two terms, we should be looking to see, do we have the difference of two perfect squares? Y squared is a perfect square, 4 is a perfect square, and we are subtracting. That means we do have the difference of two perfect squares, which would factor to y minus 2 times y plus 2. Remember, those signs have to be opposite, so when you FOIL, the OI cancels out. On the bottom, I have y minus 2. Once again, no greatest common factor, and y is to the first power. so I can't do anything else with that. But that entire entity is one factor, so I want to put parentheses around it to remind myself I cancel all of it or none of it. And now we do have the fun canceling. Anything on top that matches with anything on the bottom gets canceled out. It doesn't matter if it's right on top of each other or diagonally, as long as one of the factors is in the numerator and one of them is in the denominator. So we get to cancel. Ooh, y minus 2 over y minus 2. Ooh, y plus 2 and a y plus 2. Oh, there's another y minus 2. Can't I cancel that? No, this one's already canceled. It's gone. You can't cancel it twice. So what am I left with? Well, we're left with just that quantity, 4 times the quantity of y minus 2. Leave it in factored form, because if we want to do something with that, we like factored form an awful lot. Don't feel like you have to multiply anything. So to simplify, we factor and cancel. To multiply, you factor and cancel. To divide, you flip the second fraction and then multiply by factoring and canceling. And that's how to simplify, multiply, and divide rational expressions. Let's do a little review of something that we've done in the past. In the past, we've talked about LCMs, least common multiples. And I've said in the past that we want to make sure that we do not focus on the word least. That is just an adjective. It's describing your noun. The noun is also not the common, that's another adjective. It's even closer related to our noun. The noun in LCM is the M, which stands for multiple. When we multiply numbers together, our result is a multiple of each of the originals. So multiples get big because we multiply to get multiples. So when we're finding the least common multiple, we're finding a larger number, something that they both have a common multiple of. Common means that they have one that's shared. Now, they have lots of different numbers that they share. Which one do we want? We want the least common multiple. So we want the smallest one that they all share. So when we're talking about an LCM, do not stop at L thinking, oh, that's least and that's small. Go to your noun, which is a multiple. Okay. So for our first example, we have 2x squared, we have a 6xy, and we have an 18y squared. We want to find a multiple of all three of these terms that's common, and it's the smallest one. So since they are all monomials, or one terms, I want to look at the numbers first. And I say, okay, 2, 6, and 18. What's the first number, the first multiple that they all share? Don't go with 2, that's a greatest common factor. That's the inside stuff. We need to go bigger. Okay, so a common multiple is going to be equal to or greater than your largest number. Our largest number is 18, so the common multiple is going to be 18 or higher. Oh, 18. Well, 18's even, so it divides 2. 18 also divides 6, so actually 18 is the common multiple for our numbers. Now we look at our variables. The least common multiple with our variables is the highest exponent on each variable. Because I couldn't just have one x, because here I have 2. So I have 2 x's here, there's just 1 here, and no x's over here. So the common multiple is x times x, or x squared. The common multiple for our y's, that's y to the first, here's a y squared, is also a y squared. Remember, the LCM of variables is the highest exponent on that letter. So the LCM of these three terms is 18x squared y squared. Now that was just monomials. What happens if we have some uglier polynomials going on? How do I do that? When we're dealing with polynomials, we have to break it down to their factors. Because as we used to do with finding common denominators, one of the techniques that they taught us was to list out all of those factors to build up a common multiple, the smallest common multiple. So the first thing I'm going to do is factor my problems. X squared minus 4 is the difference of two perfect squares. So that factors to x minus 2 times x plus 2. The x squared plus 5x plus 6 also factors nicely. It's a nice little trinomial. We make our two sets of parentheses. Numbers that multiply to x squared would just be x and x. Two numbers that multiply to a positive 6 and add to a positive 5 is a positive 2 and a positive 3. Now, to find the LCM. The LCM has to include all of our factors, but we don't want to include repeat factors because that's how we don't get the least in the least common multiple. So what I always do is I list all of my factors of my first problem because I can't have less than what I've got. And I have these two factors, so I can't be ignoring them. Now I go to my next trinomial or my next polynomial and I say, okay, with my factors there, what factors do I have that I don't already have listed down? And you'll see that the first factor is an x plus 2, but I already have an x plus 2 here, so I don't need to put it down again. But I don't have an x plus 3, so I need to include that on my list. Remember, we just keep multiplying all these factors together. That is my LCM. A nice way of checking is that both numbers, both of our original numbers, these factors, are included in your LCM. You should be able to see how your original problems are in your LCM. Because remember, to be a common multiple, you had to have taken this binomial times something to get this. And you have to take this trinomial times something to get this. Because this is a common multiple. These are the factors of it. So here's the x minus 2, x plus 2 that makes up our x squared minus 4. And over here, we have the x plus 2 and the x plus 3, which makes up the x squared plus 5x plus 6. So both of our original problems are in the LCM. Now, why do we use or find the LCM? Just like we did way back how long ago, we need the LCM to add or subtract or solve when we're dealing with fractions. And that's next. Adding rational expressions is just like adding fractions. You have to remember that we need to get the common denominator. Because a fraction is just that. It's part of a whole. Something's broken or fractured, and we don't have all of it. We only have part of the whole. In order to add how many parts I have left over here with how many parts I have left over there, I have to have the pieces the same size in order to add them. And that's why we need to get a common denominator. So to find the common denominator, we're going to go through the same procedure that we just went through in finding the LCM, because that's what a common denominator is. The least common denominator, or LCD, is the same thing as a least common multiple. We are just applying that knowledge of finding the LCD, or the LCM, to denominators, and that's why we now call it an LCD, for a least common denominator. So the first thing I always do is factor my denominators. So in this case, I have 5a minus 10. There's only a greatest common factor there, so I pull out the 5 and I'm left with a minus 2. Remember, we are dividing out the 5 to the front, not subtracting. I like to cross out what my denominator was so that I now know that this is the only thing I have left. Remember, the 5 times the quantity of a minus 2 is the same thing as the 5a minus 10. It just looks different, but it's equivalent to it. I'm going to do the same thing over here. I have a greatest common factor of 10, So I'm going to pull out the 10, and I'm left with a minus 2. Now that I have my denominators factored, I'm going to go off to the side and say, okay, what is my LCD? Well, let's see here. I need everything from my first, so I'm going to say 5 times a minus 2. And then I go into the second and I look for anything that I don't already have. Well, I already have an a minus 2, so I don't need to put that in. That's kind of nice. 10. Well, I don't have a 10. Oh, wait a second, though. Be careful here. This is just a regular old number. What's the common multiple that the 5 and the 10 share? 10 could be factored further. 10 is the same thing as 2 times 5. So there's a shared factor of 5 already, so I don't need to repeat the 5. I just need the remaining factor of 2. And it's being multiplied to everything else. Well, those are just regular old numbers, so we can multiply those. So my LCD is 10 times a minus 2. All right, so now we found our LCD. Now what? Well, we look to see what parts are we missing in each fraction. In this first fraction, I have the 5, I have the a minus 2, but I'm missing that factor of 2. So I'm going to take this times 2. Now if I do that on the bottom, I have to do the same thing on top to keep it balanced. Now I look on the right side. I have the 2, the 5, and the a minus 2. So I already have my common denominator on that side, so I don't have to multiply it by anything. So my next step is to clean this up a little bit now that we've done our multiplication, now that we found the common denominator. 2 times 4a is 8a, all over that common denominator of 10 times the quantity of a minus 2. Plus, I didn't do anything with the second fraction because it already had the common denominator, so I just rewrite it as it is, 3a over 10 times the quantity of a minus 2. And now that my denominators are the same, I can add my numerators. You may want to write it in 2 steps. 8a plus 3a all over. Notice that we do not change the denominator. If I'm going to do all that work to make sure that the bottom is the same, I will not add or subtract the denominators. And then my last step here is to say, aha, those are like terms. I can combine my like terms. So 8a plus 3a is going to give me 11a all over 10 times the quantity of a minus 2. Always leave the denominator in factored form. I cannot simplify any further as nothing on top cancels with anything on the bottom. So I know my answer is complete. That is how we are going to do addition. Subtraction is very similar, but it does have one little thing that we need to pay very, very close attention to. So let's go through one of those next. We begin subtracting rational expressions the exact same way that we did when we were adding. We have to get the common denominator. So the first thing we're going to do is factor our denominators. X squared minus 4, we've seen that one a few times today, is an x plus 2 times an x minus 2. Once again, I like to kind of cross out my denominator to remind myself that it's not there anymore. I rewrote that expression in this form instead. Then I look to my second denominator. Oh, that's just an x plus 2. I can't do anything with that. But once again, I want to put parentheses around it to remind myself that that entire entity is one of my factors. And I have to look at it as a whole quantity. Now I go off to the side. I say, okay, what is my LCD? Once again, I list all the factors of my first denominator because I can't have less than what I got. I have an x plus 2 and I have an x minus 2. Now I go to my second denominator and I list all the factors not already listed. Well, I have an x plus 2. I already have that down here. I do not need to repeat it. So this is my LCD, x plus 2 times x minus 2. Our next step is to get the common denominator in both fractions. Since this first fraction already has the LCD in the bottom, I don't have to do anything with it. But on the second one, I only have the x plus 2. The factor I am missing is the x minus 2. So I'm going to multiply the x plus 2 times the x minus 2. If I do something on the bottom, I have to do the same thing on top to keep it balanced. Why? Because I'm taking this fraction times anything over itself is 1. A fraction like this times 1 is still going to be equal to this fraction. It's just going to look different. Okay? Now we need to be a little bit careful in our next step. We don't have to do anything with that first fraction, but that second fraction we need to multiply our 8 through. Now here's where I want you to pay close attention. Remember, we are subtracting. When we had subtraction of polynomials a couple weeks ago, we remembered that that subtraction in front of our parentheses really meant that we were adding a negative, and that negative had to be distributed through or multiplied to every term inside before you could do any addition. It's the same thing with our fractions. This particular problem is kind of nice because it only has a single term of 8 on top. So what I'm going to do is I'm going to do my change technique. That's what I like to do whenever I'm subtracting, to remind myself about my rules. So I'm going to change this. As long as you do 2 changes, you're perfectly legal. I'm going to change the subtraction to addition. And then I'm going to change the sign on top, which is a positive 8, to a negative. Change. Instead of subtracting a positive, I'm going to add a negative. They mean the same thing. And now when I use my distributive property, I'm going to remember to use the negative 8 to multiply through. So in my next step, my first fraction does not change, so that stays 11 over x plus 2 times x minus 2. But in my other fraction, I'm now adding, so I bring down the plus sign, and I distribute through that negative. Negative 8 times x is a negative 8x. Negative 8 times the negative 2 is going to make that a positive 16. My denominator now are these two factors, x plus 2 times x minus 2. Now my denominators are the same, so I can combine any of my like terms that I have on top. I go through, put it in standard form, so I'm looking for variables first. Here's my only term with a variable, so negative 8x comes first. Then I have a positive 11 and a positive 16. That's going to be a positive 27. Remember, the denominator does not change. It stays x plus 2 times x minus 2 in that next step. Then I look to see, can I factor my numerator at all, to see if I have common factors that I can cancel. And there's nothing common on top. There's nothing I can pull out, and there's nothing I can cancel. So here's my final answer. So we need to remember, with subtraction, you have to change all of the signs in the numerator after that subtraction sign. You might want to go back to the chapter on polynomials to review subtraction and how that changes things. There are 2 different styles of rational equations that we are going to solve. The first one has a single fraction equal to a single fraction, as we have set up here. In order to solve this one, we multiply our diagonals and set them equal to each other. So we'll first start with this diagonal and we multiply that together. It's going to be 4. Now that 4 has to be multiplied to this entire numerator, so it's times a quantity of x minus 7. Make sure you use your parentheses for proper notation. That will be equal to the product of the diagonal going the other direction, which is 1 times the quantity of x plus 2. The nice thing is, we just got rid of all those nasty denominators. Now we have an equation that we should be able to solve. We clean it up first by distributing through to get rid of our parentheses. There's nothing else to clean up on either side of our train tracks, so now we look to move terms. The term with the variables I always move first, because I want to make sure that I keep that positive. I have 4 x's over here and only 1 x over on this side. So I'm going to take the smaller amount of x's and bring it to the side with the larger number of x's. It's a positive x as there's no sign in front of it, so to move that term, we always add or subtract. Doing the opposite, x minus x is 0, which is what we were looking for, to get rid of it. If I do that on one side, I do the exact same thing on the other side. Remember, there's always a number there. Because if it was a 0, 0 times x would be 0 and the whole thing would be gone. There's really a 1. So 4x minus 1x is going to give me 3x. I still have the minus 28 as I didn't do anything with it. On the right side of the tracks, the x's cancel out and I'm left with this positive 2. The next step is to move the constant terms together. Now remember, if you move it from one side of the equal sign to the other side, you've got to switch signs when moving terms. Terms are the stuff being added or subtracted. I need to move this 28 because it's like the 2. Neither one of them has a variable. The 28 is negative because the sign in front of the term goes with the term. So to cancel out taking away something or a negative is to make it positive. So we add 28, and once again, whatever you do to one side, you do the same thing to the other side to keep it balanced. The 3x comes down for the ride. The 28s cancel out. If they don't, you did something wrong. And on the right side, we are now left with 30. Our last step is to divide and conquer. We need to cancel out this multiplication, so we divide. Whatever you do to one side, you do the exact same thing to the other side. This time we do it because 3 divided by 3 is 1, and 1 times anything gives us our x back. On the other side, we have 30 divided by 3, which gives us 10. So x equals 10 is our solution. Remember, whenever you have an equation, your answer will look like an equation as well, with the variable on one side and the number on the other side. In addition to that, you can always replace the variable x with its value of 10 back in the original. The left side would then equal the right side when you do your simplification. No reason to get any of these wrong. You can always check. Let's try the next kind. In this particular problem, we have a fraction minus a fraction is equal to a whole number. It doesn't matter where we have fractions and where we have whole numbers, or if they're all fractions, we are going to do the same type of procedure as I'm going to show now. Once again, this is a rational equation because our variable is in the denominator, and it's an equation because we have an equal sign. Whenever we see an equal sign, it means, hey, I'm trying to find the value of x. Now, we're going to start off to solve this the same way we do when we add or subtract. The first thing we want to do is find the LCD. In order to do that, we have to factor our denominators. Here, the x doesn't go down to anything else. It's just x is as small as you can go. X plus 2 does not have a greatest common factor. It's already x to the first power, so that can't go down any further. Once again, I'm going to put parentheses around it to remind myself I did look at it and that entire quantity together is my factor, not individually. The 2, don't be quick on the 2 over here. Remember, that's not the denominator. We are factoring denominators. 2 is the numerator. We can always write whole numbers over 1. The denominator there is a 1. which if you want to bring it with you, you can, but 1 times anything is anything, and it just goes back into hiding. Remember that 1, he, she, it is the god of mathland. So now I want to list out my LCD. I list all factors of my first denominator, so that's the x. I list all factors of my second denominator not already listed. Now this x is not the same thing as just an x by itself, because you have to look at the entire denominator here. This denominator is the number x plus 2. That's going to be different than x because you're adding 2 to it. So I need to put parentheses and include the x plus 2, that entire quantity. Once again, that's kind of why I put the parentheses around it up here, is to remind myself it's all of that together or none. And once again, you can put the 1 in there, but 1 times anything, it just kind of hides in later. Now, this is where we change steps. When adding or subtracting rational expressions, we multiply top and bottom by the missing factors. So this first fraction, I would multiply top and bottom by the x plus 2. The second one, I would multiply top and bottom by the x. And on the other side, it would be both of them, actually. I'm not going to do that when solving. Remember, the part that makes this so evil for solving is the fact that we have these denominators. Now, because we have an equation, an equal sign, and only because we have an equation, we can do this other procedure instead, which essentially will get rid of all of the denominators for us. Hallelujah! So, the procedure goes to solve, and once again, we cannot do that if we're just adding or subtracting, but because we have an equal sign, which means that we can keep life in balance, the left side can be the same as the right side as long as you do the same manipulations to both of them. It's legal. So I'm going to multiply the entire equation by the LCD. Now that's not just top and bottom, that's only the top. And it's every single term, whether it has a denominator or not. Every term gets multiplied by the entire LCD. So this 15 over here, I'm going to take this times x and times x plus 2. The 15 on this one, I'm going to take that times x and times an x plus 2. I'm going to do the same thing. You got to do it on both sides of your equal sign to keep it balanced. Take the 2 times an x times the quantity x plus 2. What's that going to do for us? Well, let's check it out and see. In the first term, I have an x on top and an x on the bottom that are being factors because they're being multiplied. So I can cancel. I'm left with 15 times the quantity of x plus 2. Remember that x on the bottom, because it canceled, became a 1. Well, when we have 1s on the bottom, we don't need to write it. Minus. What cancels here? Oh, the x plus 2 and the x plus 2. I'm left with 15x equals. Buggity bug. Nothing cancels over here. So we're going to be left with something that's a little bit bigger, a little bit uglier, a little bit scarier. That's okay. We can handle it. Now we have an equation with no denominators. Oh, this is so much nicer. Well, let's see. We've got parentheses. I'm pretty sure that we have to get rid of those next. So we're going to use our distributive property to get rid of our parentheses. The 15 gets multiplied only to the terms inside the parentheses, leaving me with a 15x plus a 30 minus a 15x is equal to, okay, now we have to multiply over here. 2x times x is 2x squared, because anything times itself is a squarey. And then 2x times 2 is 4, and the x comes along. All right, that's not so bad. After multiplying through like that, we do like to clean things up a little bit. On the left side, I notice that I have some like terms. Now they are on the same side of the equal sign, so I don't have to switch signs. I only switch signs if I cross the tracks. Here, the 15x and the minus 15x are on the same side. I'm just gathering things together on my side of the tracks. 15x minus 15x, oh, that's 0, woohoo! So I'm left with 30 on the left side. And on the right side, I'm left with 2xo squared plus 4x. Oh no. X squared, I can't combine that with an x. Okay, well, let's see. Last week we learned something about that. Last week we learned that if there's a squared and an x, I'm going to have to use my very favorite property of all time, the zero product property. All right, but I don't have a zero or a product. All right, so that means that I have to make it equal to 0. Now, the number in front of my x squared is positive. I want to keep that positive whenever possible. So I'm going to move the 30 onto the right side. It's a positive 30, so I'm going to take away 30. Now it's not like an x squared because it doesn't have an x. It's not like an x because it doesn't have an x. So I'm just going to put it way over here to remind myself that it's not like those other terms and I cannot combine them. Now be careful. I still have two sides of an equal sign. The equal sign or the equation does not go away because we took away everything on one side. 30 minus 30 is the number 0. So that is the placeholder on that side of the equal sign. And on the other side I have 2x squared plus 4x minus 30. Okay, now what are we going to do? Factor. It's all about factoring. I notice that all of my numbers are even numbers. Oh, so that's going to make it easier. I'm going to take out the greatest common factor first. Okay. All right, so now I can continue my factoring because I'm not done yet. I now have this much smaller trinomial that I can break down into two parts. X times x will give me the x squared. Negative 15, so I know I need a positive and a negative. Two numbers that multiply to a negative 15 and add to a positive 2. Well, that's going to be a positive 5 and a negative 3. Now that we're at this point, we can use my favorite property, the zero product property, which says if you have stuff being multiplied together equal to 0, this stuff has to be 0. Okay, I ran out of space here. Let me rewrite this at the top of my next page. Let's see here. It was an x plus 5 times an x minus 3. Okay. So I now can set those factors equal to 0. Now wait a second. What's up with that 2 out there? That seems way crazy. You're right, that 2 is not necessary. The 2 does not have a variable attached to it. That means that it's pretty much just a magnification number. It's not one of our values, as x is not attached to it to find a value with it. Remember, whatever you do to one side, you can do to the other side. I can multiply by whatever number I like. So to clean this up a little bit, hey, if I can multiply by anything, I can divide by anything. I'm going to take this side divide by 2 and this side divide by 2. I can do that because 2 is a number. I cannot do that if it was a variable, because that would lose one of my values. I can divide both sides by numbers, but I cannot divide it by, say, an x, because that would lose one of my solutions. So here's my zero product property. My first number here is like the a, and here's like my b that are being multiplied together. The zero product property allows me to separate those and say, okay, what would cause x plus 5 to be or equal 0? Or what would cause x minus 3 to equal 0? And I solve those by getting x by itself. Subtract the 5, x is equal to a negative 5, or add 3, x is equal to 3. So for this particular problem, we have two solutions. X is equal to negative 5, or x is equal to 3. An application to solving rational equations is called the work principle. It essentially says, hey, if you do some job and I do the same job in 2 different times, how fast would we get it done if we work together? Let's get together, yeah. All right, now we have to think about this. Say crew A does a job in 9 hours and crew B does the same job in 12 hours. How long would it take if they worked together? Now, the number one common mistake that students make on a problem like this is that they average them. They don't read the book, they don't look up anything, they just say, I don't know, 9 and 12, I don't know, 10 and a half hours probably. Now, let's think about this logically. You know, those critical thinking caps, let's put those on. If it takes crew A 9 hours to do it, and they have help, why is it now going to take them 10 and a half hours? If it only took them 9 hours without any help, I would think that with help, it would be faster. Oh, yeah, that kind of makes sense. So the work principle will help us solve this, and our time better be less than 9 hours. Otherwise, crew B is not helping us at all. Okay. So there's a formula for this. We just have to plug and chug. The formula, the work principle formula says, if you take 1 over the first person's time plus 1 over the second person's time, it will equal 1 over the time when they work together. Let's get together, yeah. So we plug in the numbers that we know. Okay. 1 over crew A, it said up here, did their job in 9 hours. So A is going to be 9. Plus 1 over B. B is this 12 hours. And we're solving for T. Now, in order to do that, we once again find the LCD, multiply every term by that LCD, and then solve. Oh, so what's the first number that 9 and 12 and T multiply into? A common multiple. Well, I'm pretty good with my multiples of 9, but maybe not so much with 12. I'm just going to go off to the side and I'm going to list my multiples of 12. Let's see, 1 dozen is 12 cookies, 2 dozen is 24 cookies, 3 dozen is 36 cookies. Oh wait, 36. That's also 4 times 9. So 36 is the first number that they multiplied to. Well, wait. It wasn't just 9 and 12. I have to remember T as well. So my LCD is going to be 36T. So I'm going to multiply every term on top only by 36T. Both sides of the equal sign. And then we see what cool thing cancels out. 9 goes into 9 once, 9 goes into 36, that 4 times. I'm left with 4T. 12 goes into 12 once, 12 goes into 36, that was 3 dozen cookies, so I have plus 3T is equal to, and on the other side, just the T's cancel, and I'm left with 36. We once again have an equation that does not have any denominators anymore, so we should be able to solve it. Combine like terms on the left side. 4T plus 3T is 7T. Ha. And then we divide both sides by 7. So we now have to kind of realize what kind of answer we should put. Because 36/7 doesn't really tell me a whole lot about my time. Well, so I'm actually going to divide this and turn it into a mixed number simply because I don't know what this represents. And since this is a word problem, I'm supposed to know what this number is. So for my class, I would be perfectly happy if you put the 36/7, but label it. What does that represent? Hours. But if you need to see, well, what the heck does 36/7 mean? Divide it. 7 goes into 36 5 times with 1/7 left over. So it's 5 1/7 hours. So 9 hours and 12 hours if they work separately. If they work together, they cut it down to a bit over 5 hours. Well worth the teamwork. So in conclusion, this is one way to look at each of your steps. Hopefully you can read this. It's typed a little small. Simplifying rational expressions. You factor the numerator and the denominator completely and cancel common factors. To multiply rational expressions. Your book likes to talk about multiplying the numerators and the denominators together. That just means write it as a single fraction as opposed to two separate fractions, because all of this is going to be all about factoring. So then you factor the numerator and the denominator completely, cancel the common factors, leave it in factored form. We don't actually multiply when it says to multiply. Dividing rational expressions. Flip the second fraction and multiply by factoring the numerator and denominator and canceling common factors. Adding and subtracting rational expressions. This is where it gets a little bit more complicated. Okay. We need that common denominator. We can only add or subtract the top if the bottom is the same. So if they have same denominators, we simply add or subtract the top numbers and simplify if possible. If we have different denominators, we're going to have to get that common denominator. And how do we find the common denominator? Let's skip down to that part. Finding the common denominator. Factor each denominator completely. List the factors in the first denominator. And then include in your list any factors of the second denominator that are not already listed. And do that for all of your denominators. The LCD is the product of all of the different factors, but we don't actually multiply. We do not multiply the factors in the denominator. Okay. So once you find the LCD, you multiply top and bottom of each fraction by the missing factors. By the missing factors. Then you add or subtract the numerators and put it on top of that same LCD. And simplify by factoring and canceling if possible. Remember, when you are subtracting, you may have to distribute through a negative sign into that second fraction to make sure that your signs are correct. Finally, solving rational equations, you're still going to find the LCD, but in this case you're multiplying the entire equation by the entire LCD and then solve from there. That'll get rid of your entire denominator so that you can have either a linear or a quadratic equation that'll be easier to solve. That was written kind of small, like we had a little bit of an issue seeing that. Let's see if we pull out for a second and go to my other summary list. This might be easier to see. To simplify or multiply, we factor and cancel. To divide, we flip the second fraction and multiply by factoring and canceling. To add or subtract, we have to find the LCD. multiply top and bottom of each fraction by the missing factor or factors of that LCD. And then we add or subtract the numerators. Remember to change the signs of subtraction if you're subtracting them. Simplify if possible, which means factor and cancel. To solve rational equations, find the LCD, multiply every term, top only, by the entire LCD. With adding and subtracting, it was the missing factors, top and bottom. When solving, it's the whole LCD on top. And then solve. And of course, you can always check to make sure that you had the right answer. And that's chapter on rational expressions and equations.